Okay, so this is the electrolysis experiment, and here are the materials that we need. So we've just got a clear Pyrex measuring cup here, and it's got some water in it. One of the things that you might do to make this experiment go better is just shake a tiny bit of salt in there, or what we've done is we've just added a little tiny bit of vinegar, and that'll help the electricity conduct through the water better. Sometimes, depending on what kind of water you get from your sink, it might be just fine. So, and then a battery, you can use an 8-volt battery or a 9-volt battery or whatever other kind of battery you can get your hands on. This is just what I had, and it works pretty good. One of the things that we might want to talk about here is the kind of battery that's easier to use. If you use a 9-volt battery, a lantern battery like this, it makes things a little bit easier because it puts both of your battery terminals on the top here, and they're easy to get to and easy to deal with. And you can see that the terminals here are labeled as this one here is the positive terminal, there's a little positive sign there, and this one is the negative terminal, a little negative sign there. And we'll talk about what positive and negative means in electricity in some of the later chapters, but for now, just note which terminal this is and note which wire the bubbles come out of. As we should see the bubbles come out of the wire that's attached to the negative terminal here. And then for test tubes, I couldn't find any test tubes around my house, so I dug some shot glasses out of a cabinet, and those are going to work. And finally, a length of wire. What you're going to need to do is strip the ends of it so that you have the copper exposed like that. And here we go. So the first thing that you want to do is wrap the wires here around the battery terminals. If you're using a different kind of battery, take some duct tape or alligator clips or anything just so that the wires stay in contact with the terminals there. So we've got that. And then these two ends are going to go into the water. Take your shot glasses or test tubes or whatever you get and fill them with water and kind of turn them upside down. What we're going to want to do is catch any gas that comes out of the wires here. Turn that so you can see it better. Okay, great. So if we stick these in, what you'll notice is that one of them starts to bubble. And you see right there on the left-hand wire, which is coming from the negative terminal, some bubbles are already starting to form. So very cool. Let's go ahead and stick these underneath our test tubes so that all those bubbles get trapped, and we'll collect them so that we can see how much is produced. This will take a while. The important thing is that there's no air in the test tubes or the shot glasses right now, as they're completely full of water. So any gas that gets trapped in there while we leave this here will be entirely from the product of this electrolysis process. Okay, so here the experiment's been going for a couple minutes, but the bubbles have really started taking off, and so this is a really good example of exactly what we're looking for. There's a lot of gas coming off of that negative wire there and collecting in the top. So we'll let it run for a second and see how much we can get and see that if it burns when we put a match in it. One that I've had running for a little while, so it's got all kinds of gas in it already, and what I'm wanting to do here is we've got water and we're tearing it apart, right? We're tearing it down to its constituent parts. So we call water H2O, and so we would expect two different gases to be produced. And we have two different gases, but not just two different gases, but there is more gas in this test tube than in this test tube. Twice as much, in fact, as you could watch them fill up, and this test tube would always have twice the volume of gas as this test tube, and that's great. This is one of the first things that suggested to physicists and chemists that there would be a proportionality in the parts of water. It's two hydrogens for every one oxygen, because there's twice as much gas on this side as on this side, and not some other arbitrary H3O4 or anything like that. What ought to happen is whenever we put the match up next close to this one, we should get a nice pop, a little mini explosion as that hydrogen combusts. And then on this one, we'll try and put a match next to it, but I'm not expecting very much to happen, as maybe the match will burn a little brighter because there's pure oxygen there, but it definitely won't be anything impressive. We might not see anything at all. So, let's see what we can do here. And if you do this at your experiment at home, make sure that you have your parents' permission. All right, let's see. There we go. There's a little pop. It burned up right through those bubbles. Excellent. And that was one of the things, we added soap here so that the bubbles would hold on to those gases. So whenever I put the flame next to it, it burned right down through all those bubbles. So whatever is going into there, it's not just air. It's not like we're just boiling the water, because whenever you boil water, you get steam, and steam, of course, does not burn like that. So that's a very important thing to know. Now let's try this other one and see if anything happens, just for fun. No, nothing. But that's kind of what we expected. So that's the experiment. Again, is what is going on here is we're getting gas out of water. We're tearing apart water, and that's a big deal, because back in the day, philosophers and scientists and chemists thought that water was an element, as that's as basic as it got, and things were made out of water, but water itself wasn't made out of anything. Well, we've just proved that wrong. We've just seen an example to the contrary, right? We've taken water, again, we have electricity, so that's kind of an unfair advantage, but we've broken it down into something that is not water at all, into two gases that float to the top of the water. They're very different, and they burn. You know, water doesn't burn, so that's it. Very interesting. We're done. Okay, so fill up, and if you do this at home, if you've got enough patience to do this, you can see that looked like it burned a little brighter.